everybody, this is section 7.6 for our Math 211 geometry class, and in this section we're going to talk about different proportions that we can use with triangles, specifically the Sidesplitter Theorem and the triangle angle bisector theorem. First up is the Sidesplitter Theorem, and this theorem says if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides those sides proportionally. So, again, if you look in this triangle, we have two sides, or two lines that are parallel. We have one here and one here. And what this line does, RS, because it is parallel to one of the sides of the triangle, it's going to divide those sides proportionally. So they're not necessarily going to be the same length, but so I really shouldn't have the same markings on there, but it will divide them proportionally. So they'll be on the same scale factor. So here we're going to use our Sidesplitter theorem and figure out what x is. So we have our two parallel lines right here. So that means we're going to write our proportion. You can actually just write it as you see it. So we'll do 12 over x plus 1 over or equal to 9 over x. And then we'll cross multiply and divide. So we end up with 12x is equal to 9 times x plus 1, and we'll distribute that. So we have 12x is equal to 9x plus 9. I'm going to subtract 9x from both sides. We end up with 3x equals 9. Divide by 3, so x is going to be 3. So then that makes this side equal to 3, and this side would be 4. All right, so we have a corollary to the Sidesplitter theorem, and this corollary says if you have three parallel lines that intersect two transversals, then the segments intercepted on the transversals are proportional. So again, we're talking about those parallel lines and the segments between them, so like CB, AB, would be in proportion or the same scale factor to WX and XY. Not necessarily the same length, but the same scale factor. They would be proportional to each other. All right, so here we have three campsites are shown in the diagram, and they want to know the length of site A along the river. So they want to know the length right here. And notice the lines between the campsites are parallel. So we have four parallel lines there. So I can set up a proportion using the information I have here. I know that 8 yards is equal to 7.2 yards on the other side. The campsite, we're going to make that x, so x over 9. So when I cross multiply, I end up with 7.2x is equal to 72. And when I divide 72 by 7.2, so I'm dividing by 7.2, and I get x equals 10. So the length along the river for site A will be 10 yards. All right, so the last theorem that we're going to talk about is the triangle angle bisector theorem. Definitely can't say that 3 times fast. And this theorem says if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So here is a ray that bisects an angle of the triangle. And what it's going to do is it's going to divide that opposite side into two segments that are proportional. So those are our two segments. They are proportional to the other two sides of the triangle. So CD over DB is proportional to the legs, like CA to BA. All right, so here, angle P is bisected by a ray. That ray is right here. So they want us to find the value of x. So again, kind of think of it, you already have it set up as a proportion. We can write it as, we could do 10 over 18 is equal to 12 over x. Or I tend to do, like I go around, so I do 10 over 12 is equal to 18 over x. And if you notice, your cross products for both, no matter how you write it, are the same. So again, it's a nice thing, you can write them differently. 12 times 18 is 216. So we have 10x is equal to 216. We'll divide by 10. So x is going to equal 21.6. And that is it for 7-6. Nice short chapter.